Dave, geotechnical is a discipline that's always first in, first out. Yep. You almost a long lost memory as soon as the detailed design is done. Where do you think the real value lies in what you do?
Yeah, sure. So, yeah, we are. You're right. We are involved at a very early stage, and projects have an evolving life cycle, I suppose. So, when a geotech is first involved, it's usually for, it might be a zone change application or a resource consent application, or it might be for early planning, depending on the nature of the project. And at that point, there's typically not a great deal of funding for the project. It's in early stages and everyone's trying to do the bare minimum, I suppose. So
for context, at this point, is the concept design complete?
Yes, normally the concept design will be complete.
Yep.
And they're just after some form of planning approval, whether it's resource consenting or some other sort of approval, even plan change perhaps. So I use the example of, say, a mid-rise building, a 5 to 7 story type building, might be an accommodation block or something like that.
Yep.
The geotech engineer will have a very limited scope, and it's typically highly competitive at that point. So price is everything. So geotech engineers are racing or scraping to the bottom of the barrel in terms of price.
Yep.
If you push scope too much, you simply won't win the work. So I guess that's in that building construction game where that's relevant. Other sectors, like government agencies, not so much. So they understand risk a lot better. But typically in the building development, it's the bare minimum at those early stages of the project.
Yep.
Yeah.
So, okay. You're racing to the bottom of the barrel, so which means you're not producing a great output at that particular point in time. You're delivering the bare minimum.
I think you're addressing what geotechnical risks may be on the site and how you may deal with those.
Yep.
It won't provide any specific detail around design, or there'll certainly still be a lot of uncertainty. Like if that building's going to be piled, you might have 3 or 4 locations where you know what the pile depth is in between. You can make an educated guess, but educated guess are very risky. And that's
especially
where a lot of
in
projects,
New Zealand.
Especially in New Zealand.
Yep.
Yeah, we are a geologically dynamic country, very young, and lots of differing ground conditions across the space of one building platform. So, just I think from that point moving forward in a project is where it becomes very critical on how it's managed and what additional investigations and what additional geotech work is done through to pre-construction and contracts let for construction.
But come back to the original question. What's the true value you add?
So the true value is providing robust ground models and to reduce the uncertainty and the risk in the ground. It's something we can't see. So everything under the ground, the job's finished, done, lovely, buildings built. No one sees what's in the ground. But we know that a large part of the risk of that building is in the ground. So
the biggest risk on most construction, high-rise buildings, is underground, isn't it?
Absolutely, it can be. Yeah, I guess there's a little more certainty once you're out of the ground. You've been there before, you've done that before, but every site has its own unique characteristics under the ground. So understanding those and the importance of a robust ground model is key to good geotech.
I can attest to that as a planner, mate. I've processed a lot of delay claims in my time.
Yeah,
and the first delay claim is always ground conditions.
And it's not always just the ground conditions, it's how the ground conditions interact with whatever work you're doing. So
absolutely.
It may be piling, it may be retaining walls. The ground conditions might be absolutely fine and consistent, but I've seen examples where you're vibrating pile casings into the ground for a perimeter retaining wall, and you do one and then you do another one next to it, and it liquefies the ground, and then all the concrete from the previous pile leaks out into the countryside. It's just that's soil behaviour as a result of what you're doing. That ground was quite stable before you come along and do your technique to improve the ground or to construct the basement or whatever you might be doing. So understanding how it's going to behave during construction, not just long term, is quite key.
Yeah, cool. Thanks for your insights on that, mate. It was pretty cool.